In the crushing black of the deep sea, the giant squid stares out through eyes 27 centimeters wide, the size of basketballs, the largest eyes ever measured in the animal kingdom. That's 3 times bigger than any fish eye, big enough to gather single photons 1,000 meters down. But these eyes didn't evolve to see food. They evolved to see one thing coming, a 16-meter sperm whale hunting in total darkness. So how does an eye detect a shadow where there is no light at all? To answer that, descend to where the squid actually lives. Architeuthis dux hunts between 300 and 1,000 meters down, and at the deep edge something absolute happens. Below roughly 1,000 meters, sunlight simply stops. Not dims, stops. No surface glow, no twilight, no gradient. The water turns to a black so total that the only light left is the light made by living things. This is the zone oceanographers call the bathypelagic, a layer that begins near 1,000 meters and runs down to about 4,000, and it makes up the largest habitat on the planet by volume. The temperature here hovers between 2 and 4 degrees Celsius, and the pressure at 1,000 meters is roughly 100 atmospheres, 100 times the weight of the air you breathe, pressing on every square centimeter of flesh. That living light is the entire visual universe down here. Faint blue sparks, cold flashes, the occasional glowing smear of disturbed plankton. And into that near lightless void, evolution planted an organ almost comically large. The whole eye reaches 27 centimeters across. The lens alone can swell to the size of an orange. It is an enormous, expensive, delicate instrument aimed at a world that offers almost nothing to see. To grasp the scale, a human eye measures about 2.4 centimeters across, and the eye of a blue whale, the largest animal ever to live, is only around 15 centimeters. The giant squid's eye nearly doubles that, packed into a head barely a fraction of the whale's size. And that is where the mystery begins, because on paper, an eye this big makes no sense. Consider the swordfish. Its eyes are about 9 centimeters wide, and it tracks fast, agile prey with no trouble at all. 9 centimeters is already a formidable eye, so why would the squid build one 3 times larger? Bigger eyes are not simply better eyes. They cost enormous energy to grow and maintain. They are fragile. They present a large, vulnerable target. And physics says the payoff flattens fast. For nearly every task a predator's eye performs, the improvement climbs steeply up to about 9 centimeters, and then barely climbs at all. Past that point, you spend more and more to see almost nothing new. The reason is a principle called diminishing returns on aperture. Doubling a lens's diameter roughly quadruples the light it collects, but the resolving and detecting benefits do not scale in step once an eye clears about 9 centimeters. Beyond that threshold, the added tissue is mostly dead weight, a cost with no matching reward, unless the animal faces some rare and specific problem that a small eye simply cannot solve. So an eye that keeps growing past 9 centimeters all the way to 27 is a biological extravagance that demands an explanation. In 2012, a team led by the vision scientist Dan Erik Nilsson decided to find one. They built a mathematical model of the giant squid eye and asked it a blunt question. What does an eye this large do that a smaller eye cannot? Nilsson, based at Lund University in Sweden, is one of the world's foremost authorities on the evolution of eyes, and his model folded in the optics of the deep-sea lens, the density of bioluminescent flashes in the water, the noise generated by the eye's own photoreceptors, and the swimming speeds of the animals involved. It was less a guess than a full physical simulation of what a squid could actually perceive at depth. The answer changed how we understand the whole animal. Nilsson, working with Eric Warrant, published the result in the journal Current Biology in 2012. The gigantic eye offers almost no advantage for ordinary prey. It pays off for exactly one kind of target, and only one. That target is a large, moving object detected at extreme range in the dark. The model showed that a 27-centimeter eye can reliably spot something larger than 2 meters across from about 120 meters away. A smaller eye, the sensible 9-centimeter kind, fails at this task. It cannot gather enough scarce deep-sea light to resolve a big shape that far off. Only the monstrous eye can. Detection at 120 meters is the single job that justifies the whole expensive design. The math was stark. Shrink the eye to 9 centimeters, and its useful detection range for a giant moving object collapses to roughly a third, buying the squid only tens of meters of warning instead of 100. In a race against a diving predator, that difference is the difference between escape and death. What large, moving thing 120 meters away in the black is worth building the largest eyes on Earth to detect? The answer has teeth, and it dives. The sperm whale is the deep sea's apex hunter, and it comes down into the squid's exact neighborhood. These whales dive routinely to between 1,000 and 2,000 meters, plunging straight through the layers where giant squid live. And a sperm whale is not subtle. It can reach 16 meters long and weigh around 45 tons. That is a moving object far larger than 2 meters, arriving in the dark, precisely the shape the squid's model eye is tuned to catch. A single dive can last between 45 minutes and over an hour, and tagged whales off places like the Azores and Kaikoura in New Zealand have been tracked plunging past 2,000 meters, one record dive reaching an astonishing 250 meters. An adult sperm whale eats around a ton of prey a day, and much of that catch is cephalopod flesh torn from the very depths the squid calls home. We know beyond doubt these two animals collide because the evidence is inside the whales themselves. Sperm whale stomachs are full of hard, indigestible squid beaks, thousands of them, the durable jaws that survive digestion when everything soft is gone. Those beaks are a body count. They prove sperm whales hunt giant squid relentlessly, generation after generation. In one examined stomach, researchers counted more than 18,000 squid beaks, an entire feeding history preserved in chitin. By measuring the size of those beaks, scientists can even estimate the size of the squid each one belonged to, reconstructing meals from creatures no human ever saw alive. And the whale hunts with a weapon the squid cannot match. Sperm whales navigate and locate prey using echolocation, firing powerful clicks into the dark and reading the echoes that return. The squid has no such sense. It cannot hear the whale coming the way the whale hears the squid. It is effectively blind and deaf to sound. All it has is light, and there is almost no light. So how does it survive? Those clicks are the loudest biological sound on Earth, measured at up to 230 decibels underwater, and the whale can detect prey with them from hundreds of meters away, sweeping the black like a living sonar array. Against that, the squid brings nothing but a pair of eyes. The trick is that the whale betrays itself with light it never meant to make. The deep sea is seeded with bioluminescent plankton, tiny organisms that flash when disturbed. The most important are dinoflagellates, and when something jostles the water around them, they fire off cold blue-green light at a wavelength near 470 to 480 nanometers. Now picture a 45-ton body plowing through that living soup. As the whale moves, it disturbs the plankton across its entire enormous surface, and they answer with light. The result is a vast, faint, glowing outline, the shape of a whale sketched in cold fire by the water it displaces. The whale becomes visible not because it glows, but because it makes the sea glow around it. Dinoflagellates, like species of Noctiluca and Pyrocystis, respawn within milliseconds of being jostled, flashing for a fraction of a second before falling dark again, so the glow ripples continuously along the moving body, a trailing halo that renews itself as the whale advances. And here is the elegant part. The squid's eye is tuned to detect exactly this. Its sensitivity peaks in the same blue-green band the plankton emit. The eye is built to catch one specific, faint, spreading pattern of light in the dark, the signature of a huge body in motion. Everything about the organ, its size, its tuning, its light-gathering power, points at that single warning. But warnings are never free. Eye tissue is among the most metabolically expensive tissue an animal can carry, demanding constant energy simply to exist and function. The squid pays that bill continuously, in the dark, where food is scarce, and every calorie is hard-won. Why pay it? Because the larger the lens, the more photons it gathers. And in a world starved of light, sensitivity is everything. A bigger lens scoops up more of the few available photons, and only with that flood of light can the eye see the whale's faint glowing outline at a useful distance. The squid grows to as much as 13 meters in total length, a body vast enough to house and feed these organs, and evolution decided that expense was worth it. Females are the larger sex and can exceed the males by several meters, and the two long feeding tentacles account for much of that total length, whipping out to seize prey and, in a crisis, to grapple. The heaviest confirmed specimens have approached a ton in mass, a body plan built at giant scale precisely so it can carry giant eyes. And notice what evolution deliberately gave up. It did not optimize these eyes for sharp, detailed vision, the kind that would help hunt small, darting prey. It optimized them for raw sensitivity, for detecting a warning at maximum range. In the deep, seeing a threat coming beats seeing anything clearly. The squid traded resolution for early warning and paid a fortune in energy. So follow that logic to the moment it exists for. A sperm whale, hunting through the black, crosses an invisible line 120 meters from the squid. At that instant, the faint glowing shape resolves in those enormous eyes. The alarm fires, and 120 meters suddenly becomes the thin margin between life and death. That margin is measured in seconds, but seconds are enough. A giant squid can jet away at high speed, blasting water through its funnel to rocket clear of the descending predator. Without the early warning, the whale would be on it before it moved. With it, the squid gets a head start, a running lane through the dark. The sperm whale is its primary predator, and these seconds are the whole reason the eye exists. And when the warning fails, when the whale closes anyway, we see the wreckage written on the hunter. Sperm whales surface with their heads ringed by circular battle scars, the marks of giant squid suckers. Those scars prove the squid does not always flee. Sometimes it fights, and it leaves its signature on the flesh of the largest predatory animal alive. For decades, all of this was inference. The calculations, the beaks, the scars, the tuned pigment all pointed to the same drama, but no human had watched it happen. The giant squid was a creature of dead specimens and educated guesses. Then, at last, we saw it live. In July 2012, off the coast of Japan, the first footage ever recorded of a living giant squid in its natural habitat was captured. A team led by the Japanese scientist Tsunemi Kubodera, working with NHK and Discovery, took cameras down to about 630 meters, near the Ogasawara Islands, and waited in the dark. Kubodera, of Japan's National Museum of Nature and Science, had already photographed a live giant squid in 2004 and filmed one at the surface in 2006. But this 2012 expedition marked the first time the animal was captured on film hunting in its own deep-sea world. The team logged some 100 dives in a small submersible over hundreds of hours, lured the squid with bait, and used specialized dim red and blue lighting invisible to the animal's eyes so as not to frighten it away. The individual they filmed was roughly 3 meters long, and had it possessed its full tentacles, it would have stretched to around 5. And there it was, alive, moving through the black at the very depths the theory predicted. The footage confirmed the animal in its true element, in natural darkness, no longer a corpse hauled up in a net, but a living hunter with those vast eyes turned outward, watching for the shape that could kill it. With that living proof in hand, the evolutionary answer finally settles into place. Those basketball eyes are not a hunting tool. They are an anti-predator adaptation, an early warning system built around a single deadly threat. They are optimized for long-range detection, and in the lightless deep, sensitivity beats resolution every time. That is why no other animal on Earth ever evolved eyes this large. Only the colossal squid, Mesonychoteuthis, comes close to rivaling them, and it faces the same predator in the same dark. And that is the deeper lesson. Vision does not evolve towards some abstract ideal of clarity. It evolves to match ecological pressure, to solve the one problem that most often decides whether an animal lives. Here, the predator-prey arms race pushed a sense organ to a physical extreme, growing an eye until it could catch a whale's glowing ghost at 120 meters. You see the same force elsewhere in these waters. Deep-sea gigantism is common among cephalopods, bodies swelling to impossible scales, shaped by cold, pressure, and the relentless demands of the hunt. And the relationship at the heart of this story never ends. Squid remain a vital part of the sperm whale's diet, so the pressure that built the eye keeps pressing, generation after generation, in the dark. So when you next hear that the giant squid has the largest eyes in the animal kingdom, remember what they are actually for. Giant eyes evolved to see death coming. Not to find a meal, but to spot the shape of the one thing hunting them, painted in cold plankton light 100 meters off in absolute black. The most extraordinary eye on Earth is, at its core, a fear-made flesh, a survival machine staring into the dark for the whale. If this dive into the deep sea's strangest survival story stayed with you, consider subscribing so the next lore film can find you.